Hello everyone, welcome to mathematics class standard 6 chapter 7 which deals with sets. A new chapter for you, a set and its objects. Today we are going to discuss about a set and its objects and the terms related with it. First we discuss about what is objects. In mathematical language, everything in this universe which is living or non-living is called an object. Means everything which is living or non-living existing in the universe is called an object. Well-defined collection of objects. A collection of objects is said to be well-defined if it is possible to tell beyond doubt whether a particular given object belongs to the given collection or not. Set. A well-defined collection of objects is called a set. A well-defined collection of objects is called a set. The objects in a set are called member or element or point of the set. A set is usually denoted by capital letters such as capital A, capital B, capital C, capital D, etc. And its elements are denoted by small letters small a, small b, small c, small x, small y, small z, etc. If X is an element of a set A, we write it as X belongs to A, which means X belongs to A. If X is not an element of a set A, we write X does not belongs to A. And it is customary to put the elements of set within the braces separated by commas. The elements of a set are kept within the braces and each element are separated by a comma. Let A be the collection of first 5 natural numbers. Then A is equal to set A. Set is represented by capital A. So set A is equal to curly bracket start 1, 2, 3, 4, 5 and end of curly bracket. You see here the elements 1, 2, 3, 4, 5 are separated by comma and these elements are kept within the bracket. So 1, 2, 3, 4, 5 are elements of set A. Here A1 belongs to a set A, 2 belongs to set A, 3 belongs to set A, 4 belongs to set A, 5 belongs to set A, 6 does not belong to set A. You see in this set A, there is no 6, 6 is not there, so 6 doesn't belong to A, 7 doesn't belong to A. Let B be the collection of all vowels in the English alphabet. So set B is equal to curly bracket start A, E, I, O, U. These are the vowels of English alphabet and they are kept within the braces and each element is separated by comma. You see A, small a, comma, small e, comma, small I, comma, small o, comma, U. So set B is a set and whose elements are A, E, I, O, U. You see the elements A, E, I, O, U are written in small letter but set is written in capital letter. So A, E, I, O, U are the elements of set B. A belongs to small a belongs to set B, small b belongs to set B, small I belongs to set B, O belongs to set B, small u belongs to set B. Consider the collection of all interesting books in a library. A book may be interesting to one person and it may not be interesting to other persons. So we are not definite as to which books are there in our collection. Means we cannot define which books are interesting and which books are not interesting. There will be not a well defined collection of interesting books. So the collection of interesting books in a library is not well defined. Hence, this collection is not a set. Hence, collection of interesting book is not a set. It is not a well defined term. So you cannot identify which books are interesting and which are not interesting. For example, some books are interesting to me, but these books are not interesting to you. So you cannot say these books are which books are interesting and which books are not interesting. So it is very difficult to get a collection of interesting book. So we cannot define it properly. So the collection of interesting book is not a set. Consider the collection of young players of Delhi. There is no specified age to be young. Here there is no specific age to which age group is said to be young. So we cannot say definitely who are members of this collection. Hence, collection of young players of Delhi is not a set. We cannot easily identify which players are young and which are not young. It is not well defined, so you cannot say which players are young and which are not, which are not. So collection of young players of Delhi is not a set. Example 5. Consider the collection of rich persons of Chennai. There is no specific definition of a rich person. It is not a well-defined term. Rich person of Chennai is not a well-defined term. So the above collection is not a set. Good players, intelligent boys, honest person, tall boys, beautiful girls, etc. do not form a set. Because it describes the quality of the object. So they don't form a set. How to describe a set? The following three ways of describing a set. One is a roster method or tabular form, description method. Number 3, rule method or set builder form. First, number 1, roster method or tabular method form. Under this method, we just make a list of the members of the set and put them within the braces and keeping separating them by putting comma one after another. The order in which the elements of a set are listed is immaterial. It means that the elements of a set can be written in any order. Let A be the set of all even numbers less than 15. Then even numbers less than 15. 2, 4, 6, 8, 10, 12 and 14. These are the even numbers. So set A is equal to 2, 4, 6, 8, 10, 12 and 14. Example 2. Let B be the set of all prime numbers less than 20. All prime numbers less than 20 are 2, 3, 5, 7, 11, 13, 17, 19. So set B is equal to 2, 3, 5, 7, 11, 13, 17, 19. Example 3. Let C be the set of all two-digit numbers, the sum of whose digit is 7. Then, so set C is equal to 16, 25, 34, 43, 52, 61, 70. You see, the sum of the digits of each of the number is 7. D be the set of all letters of the word Kolkata. The distinct letter in the given words are K-O-L-A-T. So D is equal to K-O-L-A-T. K is written twice, A is written twice. So we take only once. While representing them, we take only one time. We write only one time. Every repeated element is taken only once in a set. So this is about the roster method or tabular form. Now we discuss about description method. Under this method, we just give a description of members of the set and put it within the braces. Means, and in that method, we just give the description of the elements of the set by keeping in view a common characteristics of the elements and put it within the braces. Let A be the set of all natural numbers less than 20. Then we write A is equal to natural numbers less than 20. Let B be the set of all days of a week. Then we write set B is equal to all the days of a week. rule method or set builder form. This method 3, third method, rule method or set builder form. Under this method, we list the properties satisfied by each element of the set. We write X such that X has properties P, which means that the set of all those X such that each X has properties P. Symbol. This symbol stands for such that. We sometimes use the symbol bar for such that. Let set A is equal to 1, 2, 3, 4, 5, 6, 7, 8. Then in set builder form, we write it as set A is equal to X such that X is a natural number. X is less than 9. Let set B is equal to 5, 7, 11, 13, 17, 19, 23, 29. Then in the set builder form, we write it as set B is equal to X such that X is a prime number. X is greater than 4 but less than 30. Example 3, let C is equal to 1, 2, 3, 4, 6, 8, 12, 24. Then in set builder form we can write it as C is equal to X such that X is a natural number. X is a factor of 24. 1, 2, 3, 4, 6, 8, 12, 24 are the factors of 24. So we write it as X is a factor of 24. Now geometric figures as a set of points. Geometrical figure is defined as the set of points satisfying certain specified conditions. A circle is a geometrical figure defined as set of all points in a plane that are at a constant distance from the fixed point in the plane. Thus, here OP is the radius of the circle. Here O is the fixed point. Represents a circle with center O. O is the center of the circle. OP is the radius of the circle. P is a point on the circle. A line segment AB is a set of infinite points denoted by AB, line AB, AB bar. And AB bar represents line segment AB. This is a line segment. A triangle ABC is a set of infinite points of the line segment AB, BC and CA. This is the triangle. A quadrilateral ABCD is a set of infinite points of the line segment AB, BC, CD and DA. This is all about the set and how we represent set, the geometrical figures as a set of points. And exercise 7a is based upon this concept. So let us solve some examples. Which of the following are set? If not set, give reason. All citrus fruits. Yes. All citrus, the collection of all citrus fruit is well defined, so it is a set. The collection of all tasty fruits is not a set because people may differ on whether a given fruit is tasty or not. It depends that some fruit is tasty to me and that is not to you. So collection of tasty fruit is not a set. The collection of all pink flowers in a nursery, it is a set. The collection of all musical instruments, it is also a set. The collection of all left-handed batsmen, it is also a set. The collection of good school in Delhi is not a set because people may differ on whether a given school is good or not. So a good school in Delhi, collection of good school in Delhi is not a set. The collection of all collection of all competent teachers of your school is not a set because the people may differ whether a teacher of your school is competent or not. The collection of 3 days of a week is not well defined because it is not known which 3 days of the week are to be included in the collection, so it is not a set. The collection of 5 months of a year is not well defined since it is not known the 5 months of the year. It is which 5 months of the year are to be included in the collection. The collection of last 5 months of a year is a set clearly. Last 5 months means it is very clear which months are to be included. Rewrite each of the following set in raster form. A is equal to x such that x is a prime factor of 42. So list all the prime factors. Hence A is equal to prime factors of 42 are 2, 3 and 7. Hence set A is equal to 2, 3, 7. X set B is equal to x such that x is a month of the year having less than 30 days. Only month having less than 30 days is February. So set B is equal to February. Now example 3, represent each of the following sets in set builder form. Set A is equal to April, May, June, September and November. So in set builder form, we can write A is equal to x such that x is a month having 30 days. You see April, June, September and November. These months have 30 days. 11, 13, 17, 19, 23, 29, 31, 37. X such that x is a prime number. X is greater than 10 and less than 40. So exercise 1A is based upon all these things we have discussed. You try to solve, and if you found any difficulty, you post in the group. Now, some important terms. Equal sets. Two sets A and B are said to be equal if every element of A is in B and every element of B is in A, and we write A is equal to B. Before taking some examples of equal sets, following discussion is important. Remark 1. The order in which the elements of a set are listed is immaterial. Thus, we write in a set 1, 2, 3 is equal to the elements 2, 3, 1 is equal to 3, 1, 2. In any order, in any set, if the elements are arranged in any order, it doesn't matter. It is the same set. The repetition of elements in a set is meaningless. Thus 1, 1, 2, 3, 3 is equal to 1, 2, 3. We have to write the elements only once. 1, 2, 2, 3, 1, 2, 3, etc. Examples of equal sets. Let set A is equal to set of letters in word wolf, and set B is equal to set of letters in the word follow. Then we have A is equal to W, O, L, F. Are the elements of set A. Set B is equal to F, O, L, W. So set A is equal to set B, since every element of A is in B and every element of B is in A. Empty set. A set having no element at all is called an empty set or a null set, and it is denoted by phi. In a raster form, we write phi is equal to only curly bracket and nothing in the curly bracket. Examples of empty set. Let A is equal to x such that x is a natural number and x is greater than 1 and less than 2. There is no such natural number. So set A is an empty set. So set A is equal to phi. Let B is equal to x such that x is an even prime number. X is greater than 5. There is no such prime numbers which is greater than even prime number. There is no such even prime number which is greater than 5. So B contains no element at all. This is why, therefore, set B is equal to phi. Example of single sets. Let A is equal to x such that x is a prime even number. Then set A is equal to 2 is clearly a singleton set. Singleton set means a set containing exactly one element is called a singleton set. Non-empty set. A set containing at least one element is called a non-empty set. Thus, a non-empty set if A is not equal to phi. Singleton set. A set containing exactly one element is called a singleton set. For example, x shows that x is a prime and even, so A is equal to 2. This is clearly a singleton set. Let B be the set of months having less than 30 days. So clearly B is equal to February. B contains only one set element, so it is a singleton set. Finite set. A set which is either empty or contains only finite number of elements is called a finite set. The number of distinct elements contained in a finite set A is called the cardinal number of A, denoted by cardinality n of A, and it is read as cardinality of set A. The number of distinct elements contained in a finite set is called the cardinal number of set, denoted by n of A. It is read as cardinality of A or cardinal number of A. Since phi contains no element at all, we have n of phi is equal to 0, or cardinal number of phi is equal to 0. Cardinality of set phi is equal to 0. Examples of finite sets: A is equal to 2, 4, 6, 8, 10 and 12 is a finite set. The number of elements in set A is 6. Therefore, cardinality of set A is equal to 6. Set B is equal to 1, 3, 5, 7, 9 up to 99. It is also a finite set because cardinality of set B is equal to 50. Sometimes we cannot count the objects of a finite set, but we know that the counting process will surely come to an end. Thus, each one of the following set is a finite set. All persons on earth, all rivers on earth, all trains in the world, all planets of the solar system. Our counting process will go endlessly, but our counting process will surely come to an end. So those kind of sets are also known as finite sets. Equivalent set. Now discuss about equivalent set. Two sets A and B are said to be equivalent sets only when cardinality of A is equal to cardinality of B, and we write it as set A equivalent to set B. For example, if set A is equal to 2, 3, 4 and set B is equal to 5, 6, 7, then cardinality of set A is equal to cardinality of set B, which is equal to 3. Means set A and set B has A and B has cardinality 3. So set A equivalent to set B. Infinite sets. A non-empty set which has not finite is called an infinite set. If we go on counting the elements of an infinite set, then the counting process never comes to an end, or the counting process never ends. For example, examples of infinite sets: consider the set n of all natural numbers. We write it as set n is equal to 1 curly bracket start 1, 2, 3, 4, 5, 6 and so on. Curly bracket ends. Means there are infinite number of natural numbers, so we cannot count the elements of the natural numbers. So the set of natural numbers is also an infinite set. The set example 2, set E is equal to 2, 4, 6, 8, 10, 12, etc. and so on. For all even natural number is an infinite set. Set O is equal to 1, 3, 5, 7, 9, 11 and so on. Of all odd natural number is an infinite set. There are infinite number of odd natural numbers. There are infinite number of even natural numbers. Set W is equal to 0, 1, 2, 3, 4, 5, 6 and so on. Of whole numbers is an infinite set. Integers, set I 0, 1, 2, 3, 4, minus 1, minus 2 and so on. 0, minus 1, minus 2, minus 3, minus 4 and so on. Of all integers is also an infinite set. Let set B be the set of all points on a line AB. This is a line and the set of points on the line. There are infinite number of points on the line AB. Therefore, the set of all points on the line AB is also a set of infinite set. So exercise 7b, based upon these facts or concept we discussed now, I hope this video will help to make you understand the chapter set. I have tried my level best to make you understand this concept, and I hope you can understand it better and clearly. And thank you so much